Welcome back to my YouTube channel. If you're not a subscriber, please subscribe right now. So today we'll be going over past question 3. So question 3 says, before we go on further, if you have any video requests, you can send them to 0978957975 on WhatsApp, or you can use my email davidcbanda237@gmail.com. So we have got question 3. It says a car with a mass. I think we can write it down on that while we are reading out the question. So it says a car with mass of, so I've got mass of the car is equal to 1,300 kg, and then is constructed so that each frame is supported by 4 springs. Each spring has a force constant of 2,000 newtons per meter. So now I've got the spring constant, K, being equal to 2,000 newtons per meter, and then I've got 2 people of combined mass. So I've got the mass of the people is 160 kg. Find the frequency of vibration of the car after it is driven on a pothole in a road and the car oscillates vertically. So now here the car here we're being told to find the frequency of the vibration. So now the frequency f is just given by 1/2 pi square root of k over m. Now this question, it has the mass of people, it has the mass of the car, and then it has also spring constant of 4 springs. Each spring having this. So meaning we can't just plug in this blindly. So there are 2 approaches that we can use for this question. So the first one is we have to understand that we have got 4 cars, or we have got 4 springs in a car. So now each spring has got this spring constant. So the first thing that we can do is we can try to divide the mass by each spring. So that's assuming each of the 4 springs is going to share the load of these people, because these people have the load. So what we can do is we can get the mass. So I'm going to say the mass of the 4 people, the mass of the 2 people and the car. When you combine it, we're going to get, that's 130 plus 160. It's going to give us 1,460. So this is the total mass. So I'm going to divide this one by 3. So I'm going to get this one divided by 3. We're going to get let me just use the calculator. 1,460 divided by 4, divided by 4 for the 4 springs. Divided by 4, 365. So I've got 365 kg. So meaning each of the 4 springs is going to share 365 kg. So what we're going to do is we're going to plug it in. So I've got 20,000 divided by 365. So then when you multiply that, we're going to have 20,000 divided by 365, and then we find the square root of what's inside. Then what's inside, we're going to divide it by 2 and later divide it by pi, which is going to give us 1.178. Frequency is measured in hertz, or you can put second divided second plus 1, -1. So now the second approach that we can use is allow me to rub this part. So the second approach that we can use is we're going to find an equivalent spring constant. So I've got the car, We have got the cup that has got 4 springs. So I've got a spring here, a spring there, and a spring there. And then we're going to find the equivalent spring. We're going to assume there's one spring. Let's put all the springs together and find what the spring constant is equal to. So what we're going to do is, we're going to find the effective spring constant. So what we're going to do is, we're going to multiply this 20 by 4. That's simply adding this 20,000 4 times, because the springs are actually in parallel, not series. And the springs, we know the K effective or the K equivalent is just equal to K1 plus K2 plus K3 plus K4. So in this situation, all the K's are the same, so I'm just going to multiply this one by 4. So the K effective is going to be equal to 4 times 20,000. Then this is going to just give us 80,000. That's 80,000, yeah. So now, this 80,000, that's like now we've put the power of all the springs together. So this is like we now have one spring. So what we're going to do is we're going to get the F is equal to 1 over 2 pi 8,000 divided by 3 divided by, now the mass is like, we'll get the total mass, which is 1,460. Then the answer there will be, plug in our calculator, 8,000 divided by 1,460. The square root, the answer divided by 2, then divided by 5. Which gives us typically the same answer, which is 1.178. So you can use either of the formulas, that one or that one, but still the logic is the same and the principles that are working are still the same. So that's all from me. Remember to subscribe, and if you have any other questions, you can send them to the number that's showing on the screen.